We are now going to do an example problem of how to create a confidence interval for a population's mean. Specifically, we're going to talk about bumblebee bats. I don't know if you ever heard of them, but they're tiny little bats, and they're so tiny, in fact, that they are the smallest known mammal that exists on Earth. Bumblebee bats are called that because they're just about the size of a bumblebee, but they are bats, they are mammals. We're going to create a 95% confidence interval for the mean weight of bumblebee bats. That is, the statement we're going to come up with is, we are 95% confident that the mean weight of bumblebee bats is between something and something. How are we going to form this something? Well, we're going to form a confidence interval based on our sample's mean and the margin of error. Okay, what is the information we have from our sample? Well, here's the sample information. 15 bumblebee bats were captured. They were weighed. That's 15 bats. So n equals 15. They were weighed, and it was found that the average weight of these 15 in the sample was 1.71 grams. A gram is not very much. Not very much weight at all. So these bats really are very tiny. The standard deviation of the sample is also calculated. That's S, and S turned out to be 0.26 grams. Okay, that's our beginning information. We'll keep referring back to that. We will use this information to form our confidence interval. We know, though, that our confidence interval, when we go through it again, once again, is going to start with the sample mean, and we're going to go to the right and to the left, and this is going to be our interval, our confidence interval, and mu, the population mean, that is the mean weight for all bumblebee bats. We are going to be 95% confident is actually going to be someplace in this interval. All right. Once again, in order to calculate that, I need to know what my margin of error is, E. The formula is we use T sub alpha over 2 times the standard deviation of my sample divided by my square root of my sample size. So here we go. We need to find out what T sub alpha over 2 is going to be. Using my table, I know I want a confidence level of 95%. Here's the 95% column. I know I had 15 bats in my sample, so my degrees of freedom is one less than that, 14. And if this is readable to you, I'll read it anyway. I get a t-value of 2.145. That's 2.145. We know that from my sample that my standard deviation was 0.26. That's the numerator. We know that the sample size, not the degrees of freedom here, but we're actually using n, the sample size was 15, so we'll take the square root of that. Got my calculator right here. According to my calculator, let's see what it says. 2.145 times 0.26 divided by the square root of 15, close parentheses, is 0.143997521, which I'm going to round to 2 decimal places and just call that 0.14. Okay? So I know that up here I'm going to start at 1.71. That was my sample mean. And to create my interval, I'm going to go up 1400ths of a gram. And over here, I'm going to subtract 1400ths of a gram. And this results in a value of, I got this written down someplace. What is it? This upper end is 1.85 grams. My lower end of my interval is 1.53 grams. Okay? Pretty straightforward process what we're doing. As long as you know what the formula is for the margin of error, it's really pretty easy just to plug the numbers in and crank out your answer. So let's go back and complete our statement. We can say that we are 95% confident that the mean weight of bumblebee bats is between 1.57 grams and 1.85 grams. I like to state this just a little bit differently. There's an alternate way this can be stated. Let me say it this way. We found that our mean weight from our sample was 1.71. So we're going to use that actually in the statement. Here's our alternate statement. We are 95% confident that the mean weight of bumblebee bats is 1.71 grams with a margin of error of 0.14 grams. That 0.14 was what we calculated for our margin of error. This concludes our example of how to create a confidence interval for the mean weight of an entire population.